Okay, good morning class. So today we're looking at the exercise on determining the equation of the cubic function. We're at this point on number 6. Okay. So let's look at the first question. The charging. Okay. So you are told that f of x equal to negative x cubed plus 5 plus ax squared plus bx plus c as a point of inflection at 0 and negative 27. So the point of inflection is at 0 and negative 27. So that means you said this cubic function is actually going through that point, not so. So that function could look something like that. 0 and negative 2. How do I know it's first? It's going to be in that shape because of the negative here. Or it could be something like that. The point of inflection there. Or it could be that with that point of inflection. Okay. Any one of those three? So let's stick with the first one. So if the point of inflection occurs at that point, then we substitute 0 and negative 27 into f of x. We get the following. Negative 27 equal, wherever we see x, we put a 0. So that's simply going to be negative 0 cubed plus a times 0 squared plus b times 0 plus c, which gives me a c value of negative 27. Okay, so c is sorted. And f of negative 3 is equal to 0, which means to say this is also an x-intercept. Not so. So because we have two unknowns at this point, which is a and b, we still need to solve. Looks like we're going to go into simultaneous equations. Okay, it looks like. However, coming back to this point here, which is also the point of inflection. So the point of inflection is the second derivative. When I set that equal to 0, I get my x value out at that point. Not so. However, if we look here, we have the x value out. So we know that x is going to be 0 at the point of inflection. And the second derivative will equal to 0 at the point of inflection. So we work out our second derivative. So the first derivative is going to be negative 3x squared plus 2ax plus b. Now again the derivative, which is negative 6x plus 2a. But we know that the point of inflection occurs at 0. So f of 0, a double dash of 0 is going to be negative 6 times 0 plus 2a is equal to 0. So that falls away. So 2a is equal to 0, so a is equal to 0. So there is the a sorted out and your c sorted out. So I just need one bit of information still, which is of course this point here. My equation now reads f of x is equal to negative x cubed, and there's no b yet, so it's plus bx squared. No, sorry. Negative x cubed plus 0 x squared, which is, that falls away, plus bx, not x squared as added, plus c, which is negative 27. So because it's one unknown, I'm going to use another point. So we substitute negative 3 and 0, naming that in x and a y. So 0 is equal to negative 3 cubed plus b times negative 3 minus 27. Okay, I'm going to calculate here. So now, this is going to be negative, positive 27. You all agree with that? So that will also cancel. So b is simply 0. So the equation of this graph is simply f of x is equal to negative x cubed minus 27. So this graph is going to look something like this. Okay? Or like that. More like that. Would be the proper what's the name? So if you apply your first derivative, you're going to get negative x squared. You see that? So you see that equal to 0, you just get 0 out. Okay. So there we got the values of A, B and C. People now, in the second part of the question, they have confirmed what we just calculated now. If A is equal to B is equal to 0, so A and B is 0 then, C is negative 27, sketch the graph f of x, the inverse, f of x, the first derivative and the second derivative on the same system of axes. Showing all intercept with the axis as well as the coordinates of the stationary point or points and the point or points of inflection. So, if we look at the function, we know that f of x is equal to negative x cubed minus 27. So for our x-intercept, what do we do? Let y equal to 0. So 0 is equal to negative x cubed minus 27. Take it over the equal sign. So x cubed is equal to negative 27. So x is equal to negative 3. We take the cube root. Y-intercept, let x equal to 0. So we have f of 0 equals negative 0 cubed minus 27, which is negative 27. Okay. Then we draw. Okay, so we know the point of inflection is at 0 and negative 27. So to cut your y-intercept, your x-intercept at negative 3. So the graph is going to come close to it. So turn here. There we go. There's your f of x graph. If you're going to work out your turning point, first derivative set equal to 0. Okay? Then we're going to get negative 3x squared. Then your x-intercept and y-intercept is 0. So I'm going to draw now my first derivative graph, which is negative 3x squared graph. So x-intercept with y equal to 0 is 0, y-intercept with x equal to 0 is 0. So what we do? We let x equal to 1. So if x is equal to 1, y is negative 3. If x is minus 1, it's also negative 3. Not so. That's going to draw this point here, it's in line with the negative 3. I didn't have to put it on that side. I could have gone with the side as well. No? So that is your f of x, f dash x. The first derivative. How do we then draw the second derivative graph? We get negative 6x. Sorry? So negative 1 squared is positive 1. Times negative 3 is negative 3. Okay. That's your second derivative. You say that equal to 0 for your x-intercept. So your x-intercept, you'll get 0 out. Your y-intercept, let x equal to 0, also 0. Not so. So what do? We let x equal 1 here. So if x is equal to 1, y is... Okay, I understand why you asked that question. No, it's not. You know what's the problem here? Is that you... Yeah, you're right. Absolutely. And it's supposed to have gone with negative 3, that's why I plotted it there. So what's f prime of negative 3? It's going to give you negative 3 squared, which is negative 27. Yeah, thank you. I plotted the wrong point. I calculated it wrong. Okay. So there's that drop. If you put negative 1 in, I got negative 3, so it should have been closer there. Negative 1, negative 3 would have been about there. Okay, which makes sense in the question. Okay, let's go to the next part of the question. If for the double dash graph, which is your second derivative, so it's going to be negative 6x. There we go again, x is 0. X-intercept will go equal to 0, y-intercept x equal to 0. I'm going to put negative 3 in here. I'm going to get positive 18. Okay? So it's not going to really... Okay, I'll then just put positive 18 in here. Remember, that's about in line with this, no? As you can see. As you can see, the two y values are the same. You see that? Okay. So to generate another point on this graph, we'll either let x equal to 1. If x equal to 1, y is negative 6. If I put negative 3 in there, I'm going to get positive 18, which is approximately negative 3 and 18. As I said, if I had put 1 in here, I would have got negative 6 is approximately about here. Okay? So again, we take a ruler, we draw this graph. And that is your second derivative. Okay? Is there any confusion there? No? So the next question, question 7. Okay, for number 7, we are told to consider the function g of x equals ax cubed minus x squared plus bx plus c. G of 2 is equal to 0. Y is equal to 8x plus 16 is the tangent x equal to negative 2. So what I normally do is I draw this graph. Model of the graph. It could be this, I don't say it is. If a was negative, we will go on the other way around. Yes? Sorry? Number 7. Thanks, man. Yeah, it's really too much. I also want to change numbers. Alright, so that could be your g of x graph. I don't say it is. And we have a tangent here. The equation of that tangent is y is equal to 8x plus 16. And the point of contact is negative 2, eh? See, and some y value. With another y value, that's okay. And then we are told that g of 2 is 0. So somewhere along that curve, you've got that. An x-intercept of 2 and 0. Right, determine the value of a, b, c, showing all this recalculation. Alright. So where do I start? I start with calculating this corresponding y value. And that's how people, this is the point of intersection. So negative 2 is the same as the same value on the g of x graph as well as the tangent. Why? Because it's a point of intersection. So how do you get the corresponding y value? Substitute negative 2 into this equation. So y is, so you'll substitute x is equal to negative 2 into y is equal to 8x plus 16. Okay, so my equation is y is equal to 8 times negative 2 plus 16, which is 0. You all agree with that? Hello? Yes, very good. Right. So what else can we look at here is that if I apply my derivative, that's my general gradient, g dash of x, is a general gradient anywhere along the curve of g. If I substitute my x value into the first derivative, I get the gradient out at that point. Not so. So if I set g dash of negative 2, what would the gradient be at negative 2? What's the gradient at negative 2? 8. Can you see that, people? This, in other words, is g dash of negative 2 is equal to 8. Okay, so the gradient at negative 2 is 8. So we work out g dash of x first. So g dash of x equal to 3ax squared minus 2x plus b. Remember, this is constant, so it falls away. Okay, so g Okay, so g dash of negative 2 is equal to 8. So it's going to be 3a into negative 2 squared minus 2 times negative 2 plus b is equal to 8. Okay, that falls away. So it's going to be 4 is 12a plus 4, take it over becomes minus 4 is equal to 4. This is now equation 2. Okay. Okay, we're shorting something here. Let's substitute this in and see what we get. We're substituting 2 and 0. So that's simply going to give us, this will go into g of x graph. Okay, so 0 is equal to a times 2 cubed minus 2 squared plus b times 2 plus c. Okay? So that's going to give you 8a plus 2b plus c is equal to 4. Now taking that over the equal sign. This is equation 2. I'm missing something. What's the function g of x equal to ax squared plus, sorry, g of x equal to ax cubed minus x squared plus bx plus c. G of 2 is 0. We use that. Y is equal to 8x plus 16. We indicated that and use that as well. The tangent is at negative 2. That's the only thing I can use is still this point here. 0 and negative 2. Okay, so now we'll substitute negative 2 and 0. Why am I but hesitant to have used this? Because I was going to lean into a three-way unknown equation. Can you see it? 3 unknown. Okay, which means to say you must have used three equations. So we'll substitute that also into g of x. Okay, so wherever I see x, I put now in negative 2. So 0 is equal to a into negative 2 cubed minus negative 2 squared minus negative 2 squared plus b times negative 2 plus c. Okay, so that's now going to give us negative 8a is going to be positive 4. Negative 4 becomes positive 4 minus 2b plus c. And this is equation. This is equation 2. This is 1. This is equation 1. This is equation 2. And this is of course equation 3. Okay. So you see for equation 3, 2 and 3, what can I do? I can eliminate c. Did you see that, people? I'm going to eliminate c. Let's pull this down. So you're going to say equation 2 minus equation 3. So equation 2 is 4 is equal to 8a plus 2b plus c. Whereas minus equation 3, which is 4 equals minus 8a minus 2b plus c. People, I could have eliminated the a or the b. But why am I eliminating the c so that I can go back to equation 1 with the same unknowns here, which is a and b. Can you see that? So by doing that, I'm going to first change the signs of the line here. Now plus, and this one. Why do I need to change it? So that c and c can be cancelled. The 2b plus 2b is 4b. 8a plus 8a is 16a. Is equal to 0. Can you see that? So in other words, minus 16a is equal to 4b. So b is equal to negative 4a. This equation 4. Now what we're going to do is we're going to substitute equation 4 into equation 1. Okay? So now we're going to substitute equation 4, which is b is equal to negative 2a, into equation 1. Let's pull up equation 1 onto the screen. Equation 1 is 12a. So it will be 12a minus 4a. Why minus 4a? Because that's your b value. Is equal to 4. What is 12a minus 4a? 8a. So a is then equal to half. But remember, b is negative 4 times half, which is negative 2. Now, we got our a value, we got our b value, so now I can just calculate c. And this is from equation 3. I'm going to say now 4 equals negative 2, a is a half, minus 2 and b is negative 2, plus c. I'm calculating c now. No? So c is equal to, calculator, remember it's not going over the equal sign, so it's 4 plus 8 times a half, plus 2 times negative 2. You made a c value of 4. There's your a value, b value, and your c value. Okay, something like this would be probably worth 8 marks. Okay. Please go learn it. If you don't, my marking is just made so much easier. Okay. People 7.2, let's just pull this down here. 7.2, we are told if a is equal to a half, b is equal to negative 2, c is equal to 4, which confirms my answers there. Not so. And people, if you got the correct answer, which is normally your answers, no? Is the correct answer, please use what is given to you. Okay?
So this isn't coming tomorrow 16.
Sorry?
This isn't coming tomorrow 16.
No, it's not coming tomorrow's test.
I want to say
Sorry?
I want to
A curve sketching, a cubic function, exercise 12. Okay, but we can't let our life stand still because you're writing tomorrow. Not so? Right, so determine the equation of the tangent, which is parallel to tangent. People, if lines are parallel, what do we know? Gradients are equal. Okay. Lines are parallel, gradients are equal. So let's pull this down quickly. So it's going to be a line parallel to this here. Okay. And it's going determine the equation of the tangent to line, which is parallel to the tangent F. Okay, so in other words, this here, as you can see, it won't become tangent anymore until another point there. Can you see that, people? Will become a tangent again. You guys understand what they're asking you? So, well, what is going to be the same with regards to the two tangents? Okay, if lines are parallel, what do we know? Gradients are equal. So, what would be the same of the two tangents? The gradient. So, the gradient here is 8. Can you see that? So, what is the equation of this gradient here? Also, 8. So, y is equal to 8x plus c. Okay. So, to calculate c, I need to know the point of contact. Not so. So what we do is, what's the equation of this g of x is equal to? What's the equation? Of minus x squared plus b, which is negative 2x plus 4. Yes. Sorry? Half x cubed. Okay. This is half x cubed. So again, determine the equation of the tangent to G, which is parallel to the tangent at -2. If lines are parallel, gradients are equal. Okay, so we work out the derivative of g of x. So g prime x is equal to 3 over 2x squared minus 2x minus 2. And of course, this gradient is equal to 8. So I drop that. So I got 3 over 2x squared minus 2x minus 10 is equal to 0. One of 3 ways I can do this, or 4 ways. I can complete the square. I can use a quadratic formula. I can use a calculator. Or we can use the factors there. Okay. We already know that x is equal to minus 2 is the solution. So it will be easy to find the other one. So it's 1.5, negative 2 and negative 10. So the other x-intercept value, and as I explained earlier on, then the graph is actually going, this is going to be on that side, because that was your negative solution there. So it could be 10 over 3, and the corresponding y value you can work out now. That now also confirms that that point is correct there. So x is equal to 10 over 3, or x is equal to minus 2. That one's accounted for already. So this is the one they're looking at. Okay? So to get a corresponding y value, we'll substitute 10 over 3 into g of x. So g of x is equal to, g of 10 over 3 is equal to, so if I see a x, I put that 10 over 3. So my equation now reads, the expression 10 over 3, it's going to give you a half times answer cubed minus answer squared minus 2 answer plus 4. So that gives you 128 over 27. 128 over 27. So this point here, 128 over 27. Okay. So have I answered the question? No. Remember the equation now reads y is equal to 8x plus c. So in order to calculate c, I must substitute the point that's lying on that curve, on that straight line as you can see here, which is, so we'll substitute 10 over 3 and 128 over 27 into y is equal to 8x plus c. So we got 128 over 27 is equal to 8 times 10 over 3 plus c. So c should work out to be minus 80 over 3. That answer there, negative 592 over 27. That's my equation. Therefore, y is equal to 8x minus 592 over 27. Okay. Then they ask us to classify or determine and classify the stationary points of G, showing all the necessary calculations. So what do we say here? As we know, this is positive, so the graph is going up, then down. So again, we need to work out our first derivative. Why first derivative? Because that's how we calculate our tangent. So g prime of x is equal to 3 over 2x squared minus 2x minus 2. So what do I do with that? I set it equal to 0. Okay, so x works out to be one of two values. Okay, so we substitute. So you've got 1.5 times, what is it? Let's work out my x values. So it's 1.5, negative 2, negative 2. Give me x value of 2, and negative 3 2/3. Okay. So what we do is, wherever we see a x, we put the 2 into the original function. The original function there. Now we're going to say a third, so it's half. Answer cube minus answer squared minus 2 answer plus 4. The first one was of course 2 to be 0, but we should have known that already. A negative 2/3 gives us 1/28 of 27. As you can see, the maximum preceding the minimum there. So what we say is, your local max, it will be, as you can see, negative would come first. It's negative 2/3. And the corresponding y value of 1/28 over 27. Is that correct? And for the local max, min, did you do maximum already? So they give you 2, you want to classify, you want to prove whatever, discuss, you can work out your second derivative, and then you can substitute 2 into the second derivative. If the answer is negative, it's a maximum, and then afterwards you do negative 2 over 3 into your second derivative. If the answer is positive, it's a local minimum. Okay, so vice versa. Okay, so I'm going to throw in those points there so that we can clean the board again. That's going to be negative 2 over 3 and 1/28 over 27. Okay, and this point here of course is 2 and 0. As I said, those 2 points are switched. No? But because everything is interlinked there or intertwined, I'm not going to still take it apart. Okay. So the next question we are told, determine the point of the points of inflection of that graph. Okay, point of inflection. People, how do you calculate the points of inflection? Second derivative. And then say b equal to 0. Okay, for the points of inflection. So we know the first derivative. The first derivative is g dash of x was 3 over 2x squared minus 2x minus 2. So g double dash of x is equal to 3x minus 2. Is that equal to 0? So x is equal to 2/3. That is there. 2 over 3. And some y value. Because I wanted the point, I must work out the y value anyway, not something. So g of 2/3 is going to the original function. So I just put 2 over 3. You see the benefit of me just pressing answer. Okay? Because now, how many times would I have entered it into this calculator? So 64 over 27. That's 64 over 27. Okay. The point of inflection. Seven 7.4, sketch the graph of G. The 7.4, sketch the graph of that, its inverse and its second derivative. Not the inverse, sorry, it's gradient. On the same system, actually showing the intercept with the axis and the coordinates of the stationary point of points, with the point of points of inflection. We'll show all the necessary calculations there. Okay. So we have a lot of information in this graph already. So is minus 2n, 10 over 3. We have the turning points. So we must work out the x-intercept anyway. Okay. So how do you calculate x-intercept? So x-intercept, let y equal to 0. I'm drawing this graph first. So we have 0 is equal to half x cubed minus x squared. So what I do is I multiply this by 2 to get rid of the fractions. 0 is equal to x cubed minus 2x squared minus 2x, no 4x plus 8. Alright, but we know that minus 2 and 0 is a factor. Not so. If we didn't know that, no problem. We act dumb and we work out the factors. Okay, we put 1 in. 1 doesn't work, 2 in. If 2 doesn't work, 1 minus 1, 2 minus 2, 3 minus 3 and so on. So we go 1 equal into that. It's not 0. Negative 1. Not 0. 2. Then give me 0. So what does that mean? That means you're saying that x minus 2 is a factor. Even though I multiplied this whole story out by 2, the factor will remain the factor. Okay? So 0 is equal to x minus 2 into. So I must land up with that. X times x squared is x cubed. Negative 2 times what is 8? Negative 4. So what do I need to end up with? Negative 2x squared, and that, yeah, I got it already. Nothing needs to be added here. Or a k value of 0 must be added. So that difference of 2 squared, so it's x minus 2, x minus 2, x plus 2. So what are my factors? X is equal to 2, which is 2 in one solution, or x is equal to negative 4. We have a y-intercept of 4. Okay, so this is going to write here x is equal to plus minus 2. And the y-intercept of 4. People, this is definitely enough information to draw the graphs now. So let's go. It's going to go through 2 and negative 2 about the same width here. Okay? This is positive, so the graph goes up and down. It turns at negative 2/3, very close to 1, minus 1. So x is equal to negative 2/3. It's all by approximation. And the other turning point is at 2 and 0, which is on here. Which explains this 2 in 1 solution that we got here from the previous frame. Okay? So the graph is going to go up. Oops. You rather draw it from here, from the turning point, it's going to be easier. There's the graph. Okay. And this is, of course, standing on this point. Okay, I'm just missing this up completely here. There we go. Okay, and of course the turning point here is known as negative 2/3 and 128. No, not 128. Negative 2/3 and 128 over 27. And of course, it's the turning point 2 and 0 here. And we said that the y-intercept will be at 4. And if you test 128 over 27 must be a value greater than 4. Okay, it doesn't have to be much greater than, but it is indeed greater than 4,74. Okay. Then they ask you to draw the inverse graph. Okay, so what do we need for the inverse graph? I need the first derivative, not so. So we have worked that out numerous times in the sum already. So g prime of x is equal to 3 over 2x squared minus 2x minus 2. Once you set the calculator for your x-intercept, we let y equal to 0. So in other words, this is equal to 0. the quadratic equation. It gives us 1.5. I think it was on your, in the previous question we've worked this out already, not so? Which is also, I don't have to do this, because we know it's going to go through those points here, not so smiling, so it's going to do this, it's going to cut that -2. The actual symmetry first. X is equal to minus b over 2a, which is 4 over 3. No? So it's going to be 4x is equal to 4 over 3. The graph is going to turn on here. There. That is your G prime graph. Okay, the coordinate, if you need the coordinate of the turning point, it's 4 over 3 and some y value. How do you get the y value? By subbing 4 over 3 to the original parabola there. It's going to be 4 over 3. So it's 1.5 answer squared minus 2 answer minus 2. Of course, not be a negative number there. Answer is -2. Let's check something with me. So we do 2 minus minus 2/3. 8 over 3 divided by 2, 4/3. Yes, what's your question? Sorry? 2 over 3. Just check if this is -2 over 3 and this is 2. So add it together. Textbook might be right. Oh, I see my mistake. I took minus. My mistake. 2 over 2. Absolutely. Sorry about that. Why is the textbook saying why? Why are you saying? Didn't you do your work? Not this time. Okay, so this is 2 over 3 here. So it's 2 over 3. You'll answer -8 over 3, is that correct? -8. Thank you. So this is the G prime of X. Why am I taking this off? And of course now you have a y intercept of -2. Okay. And then of course my second derivative graph is G double dash of x is equal to 3x minus 2. So x is equal to 2/3. This is supposed to actually have confirmed this answer of mine. Okay, because we know that at the point of inflection is where the axisymmetry occurs of the parabola graph. Okay, so I shouldn't have even made that mistake there. So there we go, the graph is going through that point of 2/3. This is your G double dash graph. Okay. Okay, so in tomorrow's lesson we're going to look at number 8. Number 8, the last one? No. It's 9 and 10. So there's 3 more. We're going to look at this in tomorrow's lesson. Okay. Okay, good morning class. So today we're looking at calculus. I think we have 3 questions left with regards to exercise 13. So just follow in the answers if I miss anything. Okay. I think we need to do it. Question 8, or number 8. Exercise 13, number 8. Right, so here we are told that So here we are given g of x equal to negative x cubed minus 2x squared plus 11x plus 12. Given that, okay, so that's the same function is given there. Determine the equation of the tangent at x equal to 2. Determine the equation of the tangent at x equal to 2. So as you can see, this red line is the tangent here. Okay? So at x equal to 2, what do we know? We're going to work out our corresponding y value at 2. Okay, so what we do is we substitute 2 into g of x. Okay? So we substitute 2, we get 2, g of 2 is equal to negative 2 cubed minus 2 times 2 squared plus 11 times 2 plus 12. Let's just get a calculator quickly. So we say negative answer cubed minus 2 answer squared. Oops. 2 answer squared plus 11 answer plus 12. It's not right. Okay, 2 is for your x value, so say 2 equals. So answer, I get 18. Is that correct? Anybody work it out? No? Okay, 18. So that means you said this point is 2 and 18. Right, so we know that the point of contact is 2 and 18. So what we do is we work out our g prime of x, g dash of x. So I apply my derivative here. Why? Because that's my general gradient anywhere along the curve. So what is the gradient at 2? So if I say x, I put there 2. Okay, so it's going to be negative 3 times 2 squared minus 4 times 2 plus 11. Before I press the equal sign, of course this gradient has to be positive or negative? Negative. Why? Because it is a decreasing function. I should confirm that now. Yes, it's negative 9. Okay, which is the gradient of this curve. So the equation is y is equal to mx plus c. So y is equal to the gradient, which is negative 9x plus c. And of course the only point that this graph is going through that we know of is 2 and 18. So I'm going to substitute 2 and 18. That's remembering that's an x and a 1. So 18 is equal to negative 9 times 2 plus c. So that is negative 18. Take it out, becomes positive 18, which is 36. So my equation is y is equal to negative 9x plus 36. The sum is worth 4 marks. Okay, so please learn it. Know how to do it. Okay, it's negative 9x plus 36. Next question, we are told determine the coordinates of the point where the tangent intersect G for the second time. So the first time we are seeing a question like this. Okay. And what they're referring to here is, we know that the tangent touches the graph at one point only to us. Not so. In other words, this 2 points becomes 1 at this point. Can you see that? But if you look along this curve, what do you notice? The graph is definitely going to cut again there. Can you see that? And when I ask determine the coordinates of the point where the tangent intersects G of x, the second time, that is the point in question. Can you see that, people? So how do you work out points of intersection normally? So the two graphs equal to each other. We do simultaneous equations. Not so. So the equation of G of x is equal to the equation of the tangent. Okay, you don't have to write it down. So the equation of G of x, of course, is negative x cubed minus 2x squared plus 11x plus 12 has to be equal to negative 9x plus 36. Take everything over to one side, so 0 is equal to x cubed plus 2x squared. Now minus 9x minus 11x is negative 20x. Plus 36 minus 12 is 24. People, but we are sure about one factor. The factor that we are sure about is 2. So we know it's intersecting here already. So we know that x minus 2 is a factor. You, that kind of girl who doesn't trust yourself, you can put 2 through there. You should get an answer of 0 provided you didn't make a mistake. Okay? So we have 0 is equal to x minus 2 into x multiplied by what is x cubed? X squared. Negative 2 times what is positive 24? Negative 12. So if I multiply that, I'm going to get now plus kx. Not so. That's going to give me negative 2x squared. That is going to be kx squared. So if I add this, it must give me an answer of negative 2 x squared. Not so? So I definitely made a mistake. No. What's my mistake here? Shouldn't give you 2x. It shouldn't be giving you negative 2x squared. I should be looking here. I should be looking there. Okay? Why? Because while there we are already dividing by negative. Can you see that? So we need to look there. It will be equal to 2. So if I take that over the equal sign, so kx squared, it has to be equal to 4x squared. Therefore, k is equal to 4. So what's my factors now? X minus 2, x squared plus 4x minus 12. So what is this to us now? Trinomial. So you factorize the trinomial. It's x minus 2 and x plus 6. Okay, so in other words, x is equal to 2 or x is equal to, you see there's a 2-in-1 solution here which confirms this point of contact here. You see that 2 solutions became 1, the 2-in-1 solution there. So x equal to minus 6 is the x value of that point of intersection. So what do I do with that? I substitute negative 6 either into the straight line or into the cubic function. You see that, people? So we're going to substitute x is equal to negative 6 into the tangent. So y is equal to negative 9 times negative 6 plus 36. So it's going to give you 54. 18, 90. I'm getting 90 here. Just check this one. Right. So that is the other point of contact. Okay, which is negative 6 and 90. Alright? Okay, so whatever we needed is under the diagram thus far. Okay, the next question. Is that it? Huh? No other question to is there? 8.3. And now we are 9. Right, question 9 of exercise 30. Okay. We are told to consider the graphs of f of x equal to x cubed minus 3x squared plus 4 and g of x, so this is a cubic function, g of x equal to 23 over 9x squared minus 19 over 3x, and that is your quadratic function. Find the point where the graphs share a common tangent. So what does that mean? It means to say the tangent to the cubic function is also the tangent to the quadratic function of your parabola. Okay? So what I would do is I would say, okay, the gradient of this has to be equal to the gradient of that. By setting it equal to each other, I will find the x values at which this condition occurs at. Okay? And with that, we can calculate the corresponding y value. Okay? Find the point of the graph there. Okay? So we're going to say f prime x is equal to g prime x. The gradients are equal because that's the same gradient. So I apply my derivative to f of x, I get in 3x squared minus 6x should be equal to 46 over 9 x minus 19 over 3. So what I do with this, I find the LCM, which is 9, multiply throughout by 9, and then get 27x squared minus 54x equals 46x minus 19. Even to one side as quadratic, 27x squared minus 54 minus 46 is negative 100. Is that correct? 100x plus 19 is equal to 0. Sorry? 90. Sorry? 3 times 9.
93 is not 90.
Oh, it's not 90. Oh, I see. Now, why did you say? A little louder. 3 times 19 is 30, 40, 57. Is that correct? 57. Which now is positive 57. You all agree with that? Sorry about that. So what do I do? I use a quadratic formula. Or I use a calculator, I can complete the square. So it's going to be, or I can use the factors, no? So x equal to 3. Or x equal to 19 over 27. You all agree with that? Alright. So, let's check this is obvious. So find the point where the graph share a common tangent. Just check if I'm on the right track. Yeah, are they giving both points? Huh? Which is the 3. Strange. Can't understand why they're only giving one. Because I'm thinking here, because I'm getting 2 points here. Okay? And I'm seeing now why didn't they say points? Point to points. Okay? But now you're saying that they're only considering 3. I don't know why. I will try and check the guide and see why. So let's see what f of 3 is. So you're going to be 3 cubed minus 3 times 3 squared plus 4. So that's going to give you 27 minus 27 plus 4, which is 4. So the point is 3 and 4 only. Is that correct? It's a bit strange. I'll check now as I said. So f of 19 over 27. Can somebody just work that one out for me quickly? This chapter 8. Exercise 13. Number 9. Okay, so here we are told that they got both solutions. If x equal to 3 and f of 3 is 4, and g of 3 is also 4, so it's a common tangent. Okay, I see. Okay? They have learned something now. Alright, so what they did was, this is 100% correct in what they're saying here. Point is only 1 point. So what they did was, they substituted 3 into g of x as 1. So let's go with that. So g of 3 is equal to 23 over 9 into 3 squared minus 19 over 3 times 3. Work that out, what do we get? 4. So what do you notice? That f of 3 is 4 and g of 3 is 4. So definitely it's also a point of contact. Not so. On this side, this gave you an answer of? Sorry? 2,86. So now you do the same as we did here, but for g of 19 over 27. But I still have a problem with this now. I'll tell you now. Okay, carry on. Which is? You must put this story now in here. Negative 3 comma? 1 9. What do you notice? It's not the same. So what does that mean to say? That's why they omitted the solution here. But the problem I'm having now is that they were told that find a point or points where the graph shares a common tangent. So what happens in this case here, if I had to draw this graph, okay, that is probably where the issue comes in. If I draw this graph, that's your cubic function, and this is your parabola function. Okay? Let's say that's your parabola. So there the graph will have a common tangent. That's basically what it looks like. Okay? On the other end, well, the problem I have is if you got the graph drawn and the parabola was drawn maybe on this side, and you draw a common tangent through there, then that is what is actually transpiring in this case. Can you see there? This is a common tangent and the graphs is intersecting at that point. They didn't tell us that the graphs are intersecting at that point. You guys understand? Well, I would have considered both solutions here. Okay, and also understand why they're only considering this is because they're considering the point of contact. Okay, so the only time we can actually be quite sure of which one to omit is once we have drawn these graphs and see exactly what case is transpiring and then going with that one only. Okay, that's my take on it. I could be wrong. But yeah. Okay, so what is the point of contact? The point of contact, I'm going with the solution, okay? That I know I'm sure will be much more than what I do. I also only know a little. So let's go with 3 and 4. Okay. (9.2) Find the equation of the common tangent to the point. And also now, since I only got 1 point, it's making it life is a bit easier for us. Okay? Because now we're only working with that point. Find the equation of the common tangent at this point. So the equation of common tangent will be in the form of y is equal to mx plus c. Not so y is equal to mx plus c. So how do we calculate m? It's my gradient. I said g, when I'm going to work with f of x, then I want to save ourselves from working with fractions. So f prime of x is equal to 3x squared minus 6x. Okay? So the gradient at 3 is going to be 3 times 3 squared, which is 27 minus 6 times 3, which gives you an answer of 9. Check if that's correct. So the gradient, of course, is 9. Y is equal to 9x plus c. To calculate c, we must substitute the point that's going through the curve. Not so. For the tangent, in this case, is going to be 3 and 4. So that's going to give you 4 is equal to 9 times 3 plus c. So 4 minus 27 is negative 23. Check if that's correct. So the equation is y is equal to 9x minus 23. You all okay with that? Again, people, you need to know this. It's worth 4 marks. Okay. So 9.2 is y is equal to 9x minus 23. That is the number 1's answer. Next question, we are told sketch a graph of f and g and the common tangent at sketch f and g and the common tangent on the set of axes. Okay. So it's a cubic function. So f of x, I need to first find my value at which x is equal to 0. So let's do that quickly. People, there's many ways of doing this. Now, I'm going to show you another way today. So it's going to be x cubed minus 3 times x squared. So it's x answer cubed minus 3 times answer squared plus 4. So we start at 1. So it's not giving you 0, negative 1. That's 0. So what does that mean to say? That f of negative 1 is equal to negative 1 cubed minus 3 times negative 1 squared plus 4 gives you 0. So therefore x plus 1 is a factor. Okay. So we now go f of x is equal to x cubed minus 3x. You don't have to write this down again. So it's going to be x plus 1 into x multiplied by what is x cubed? X squared. 1 multiplied by what is 4? 4. So what must I add here? Plus kx. So that's going to give me x squared. This is going to give me kx squared. But when I add this up, it must give me an answer of negative 3x squared. Okay, so kx squared is equal to negative 3x squared minus x squared is negative 4x squared. So therefore, k is equal to negative. Not so? My equation now reads 0 is equal to, I'm working out our x-intercept here, né? With y equal to 0. So it's x plus 1 into x squared minus 4x plus 4. Perfect square trinomial, which is going to be x plus 1 and x minus 2 squared. So it's x is equal to minus 1 or x is equal to. Okay, those are my x-intercepts. As I said, I'm going to show you another way we could have done the same thing. We could have set up a table of 7. So now we're going to enter this into the calculator. It's going to be x, so it says shift or alpha, as you can see, is in what's the name there? Middle. With my x cubed. It's not 33 cubed minus 3 x squared. So it will be alpha squared. Sorry. Plus 4. Okay, so there's no g of x. We start at negative 6 to 6. Remember, we got 1, negative 1, 2, negative 2, 3, negative 3, 4, 6, negative 6. So you're going to end that, you start at minus 6 to 6, steps of 1. So we're going to look where it gives you an answer, 0 there. And lo and behold, the answer of 0 is not there. Which means to say I probably entered the function wrong. Let's check again. It's x cubed minus 3. Why am I putting answer? Okay, so you get 0 now, and there we go. You see, if x is equal to minus 1, it gave you 0 there. So that is my solution. So now I say, I substitute f of minus 1, get 0, and I conclude that x plus 1 is a factor. There's a one way, no? Otherwise, and I keep this for a very long time now, from here onwards, you'll see me use this function. Okay, if I press mode, equation 4. I'm going to factorize this. So the coefficient of x cubed is 1. The coefficient of x squared is negative 3. There's no coefficient on x, so it's 0. And the constant is 4. Your x value is minus 1. And another x value is 2. Normally there is a maximum of 3. And there isn't, so that means to say one of the two is the a repeated solution. Okay? People, do we have to show all of this here? No. We don't have to show this. Okay? Unless it states showing all calculation. Okay? But I haven't seen that happening yet. Otherwise, in my test I put there yesterday, you have to show all calculations. So I expected you to have done this. Okay? So these are the two solutions. Okay? So these are my x values. What is my corresponding y value? That's your x-intercept. What's your corresponding y value, people? There it is. Y is equal to 4. The graph is going to go up, then down. Not so. So what do we work thereafter? Work out our stationary point, which is also known as our turning points. How do we work out our turning points? First derivative. This is equal to 0. Okay. So f prime x gives us an answer of 3x squared minus 6x. So that equal to 0. Gives me 3x as a common factor, left with x minus 2. X is equal to 0 or x is equal to 2. What do I do thereafter? I substitute that into the original function. So f of 0 is 4. So the graph is turning at 0 and 4. And the other one is f of 2. If I put 2 through here is 8. 4, 12. 8 minus 12, negative 4 plus 4 is 0. Which means to say the graph is bouncing off the x-axis. Okay. So this is going to be 2 and 0. So this is your local. The graph is going first up then down. So it's local, max. And this is going to be your local minimum. Okay, did I talk about the point of inflection? No, but I will do that calculation for you as well. Okay? If it doesn't specify, you don't have to write it in. Okay? So we know the graph is going up and down. It's going to cut at negative 1 and at 2, which is double that big. The graph is also turning at 4. So there's your turning point. And it's going to bounce off here as well. So the graph is going to come through like that. And this is the graph of u. Alright. Now do you work out the point of inflection? Second derivative. Not so. So the derivative of the derivative. As I said, this question was not asked, but I'm doing it anyway. So it's double dash of x is equal to 6x minus 6. Set it equal to 0. So x equal to 1. So what do I do is I find the corresponding y value. Always substitute into the original function to get the corresponding y value. Gives me then 1 minus 3 is minus 2 plus 4 is 2. So the point of inflection is at 1 and 2. Which is happening midway between the two turning points, which is perfect there. And as you can see, we're midway between those two as well. Okay, and that's the point of inflection. If it asks you with regards to concavity, this graph is concave, down for x is less than 1. Not 2, 1. It's to do with the x value. And that is concave, up for x is more than 1. Okay. There's another question when they ask you where the graph has 3 roots, 2 roots and 1 root. Okay? We must still look at that. Alright, so that is the first half of the graph. Of the question. Then the question says g of x. Let's go with g of x. We work out our x-intercept. What do you do for x-intercept? Let y equal to 0. Not so. So So that's going to give you 23 over 9x squared minus 19 over 3x equals 0. Got a common factor here of just take x out. I know there's more than that. So it's 23 over 9x minus 19 over 3 is equal to 0. Now, as I can see, a third is also common. So x equal to 0 or 23 over 9x is equal to 19 over 3. You simplify this. When multiply this by 9, I'm going to get 23. X is equal to, what was 19 times 3? It was 57 if I'm not mistaken. So x is equal to 57 over 23. I don't think 23 can go into 57. Just check there. Huh? No. Okay. Just press SD and see what you get here. Sorry? 2,5. So it's just over this here. Can you see that? So it's 57 over 23. Right. So what do we work here after? Y-intercept. What's your y-intercept? X equal to 0. And what's your y-intercept here? 0 as of course. Okay, the graph is already smiling. And thereafter we work out our turning point. How do you calculate the turning point? First derivative. Z equal to 0, so it's going to be 46 over 9x minus 19 over 3. Again, say that equal to 0 is 46 over 9x is equal to 19 over 3. So work out what x is. So it's going to be 19 over 3. What am I doing different here? How do we normally work out turning point on the parabola? Minus b over 2a, not so. Is that correct? Minus b over 2a. So? 46. Okay, so checking that looks a bit different. Okay, coming back, how do we normally work out turning point? It's minus b over 2a. Not so, which is the axis of symmetry. But we know how to calculate turning point. First derivative is equal to 0. And I'm showing you that you can apply that on the parabola as well. Okay, to work out the turning point of the parabola. Of course, it's 57 over 46, which is half midway between this. That's x is equal to 57 over 46. And what do I do with this? I sub it back into g of x. So g of 57 over 46 equals, so you go 23 over 9 times answer squared minus 19 over 3 answer. Gives me negative 361 over 92. Is that correct? Huh? Okay, so that's 30 approximately here. So press SD and give me an idea of how far down is it? Negative 3 comma something. Okay. I like working with fractions. Was that the answer, no? Negative 361 over 92. So that's going to give you 57 over 46 and negative 361 over 90. And of course the graph is smiling. Normally from there we draw. Okay, now coming back to this point here. Where did the tangent occur? What was the x values at which the tangent occurred at? It was 3 and 4, no? That's correct. So if this is 2 comma, well, what was this answer? This here. We press SD. Sorry? This is 2 comma 5. So 3 would have been approximately here. So that point of contact would have been here. Can you see that, people? So if I should have drawn this graph beta, then this part would have intersected. Not like that. It would have intersected something like this. So that's a 2-in-1 solution then. And that would be the point of 3 and 4. As the point where the tangent, so if I draw the tangent in, this is what the tangent would look like, coming through that point in. Okay, which is of course y is equal to 9x minus 3. Okay, now only is it enough for me to have omitted the other solution. Can you see that, people? Because if I look at the other one, what was the other solution that we had? It was 19 over 27. Okay. 19 over 27 is less than 1. So 9 is less than 1. So on your F it was 2,8, which makes sense there. And then on your Y it is negative, on your G is negative 3, something, which also makes sense here. And there's no way we could have drawn a tangent like it. Can you see that, people? But if you look at initially where my concern was, we didn't have this graph to omit the other solution. And they didn't say that the graphs are intersecting also at that point. So there was too little information to have omitted the other solution at that point. If I would have said this question, I would have rather asked to draw the graph first, to give the learner the insight on why the other one was omitted. Okay. Or I would have changed the question and said the graphs are intersecting at that point as well. One of the two. Okay. Maybe a different teacher would say differently. Okay. So ask your people that's helping you, your tutors, whatever. And yeah, how they approach that side, and you can teach me how they saw it. Okay. People, the last one. Okay. That's also the reason it takes a long time to go through this, why I didn't do it the whole exercise before. But now we're doing it. So you guys are special, no? Keep on thinking that. Right, people, number 10, the last one of exercise 13, we are told to consider the graphs of f of x equal to negative x cubed plus 3x squared minus 2, and g of x equal to 3x squared minus 3x. People, the first one is a cubic function and a quadratic function. Find a point where the graphs share a common tangent. So I think this is going to go down the same route, but I would assume that is again the point of intersection there, because we're going to land up again with two solutions there. Okay. Alright, so let's go. So we can say f prime of x is equal to g prime of x, which is negative 3x squared plus 6x minus, minus 2 equals 6x minus 3. So everything to one side, so 0 is equal to 3x squared. That cancels, minus 3. Divided by 3, and then difference of two squares. So x equal to plus minus 1. So what I do is I work out f of 1 and then g of 1. Or g of 1 then f of 1. So f of 1 is equal to, I put 1 through here, it's going to be negative 1 plus 3 is 2, and 2 minus 2 is 0. Then you work out g of 1. It's going to give you 1 times 3 is 3, minus 3 is 0 again. So according to the first sum in number 9, they're looking at it to be also the point of contact. Okay. Let's work on the other side. F of minus 1, if I put negative 1 in here, I'm going to get positive 1. Plus 3 minus 2, which gives an answer of 4, which is 2. And g of negative 1 is equal to 3 plus 3, which is 6. And they have omitted this again, I'm sure. No? Let's check there. So the point of contact is of course going to be at 1 and 0. Let's look at number 10.2. Again, we are told that find the equation of the common tangent at this point. So the equation of the tangent will be in the form of y is equal to mx plus c. Not so. So we go with the gradient, your general gradient anywhere along the curve. Okay, it's going to be a negative 3x squared plus 6x. I could have used this would have been a bit easier. So the gradient at 1, it's going to give you negative 3 times 1 squared plus 6 times 1. Give you an answer of 3. So that's a point of, that's the gradient of this curve. So the equation is y is equal to 3x plus c. Of course, we're going to substitute in the point of contact, which is 1 and 0. 0 is equal to 3 times 1 plus c. C, of course, is negative 3. My equation is y is equal to 3x minus 3. Please check if that's correct. Yeah. I'm feeling better. Y is equal to 3x minus 3. Alright, next. Sketch a graph of f and g and the common tangent to the same set of axes, on the same set of axes. Okay. So let's go. So the f of x graph is going to give us an answer of shift 4. So it will be negative 3, 3, no x, and of course negative 2. Let's check the right. Not negative 3, negative 1. Okay, the coefficient of x cubed is negative 1, 3, no x, and negative 2. So it's going to be x is equal to negative 1, so it says 1 minus root 3. There's 1 minus root 3. Just remember that's negative 0.7 something. Okay. And then of course the positive one of that. No, is the other one. 1. So if 1 is here, that second root has to be on the inside of it. No, on the outside. Alright, nice. So 1 is there. Will be on the outside. So it's going to be 1 plus 2. Okay. So you're going to cut those 3 points. It has a y-intercept at negative 2. Not so. This graph is going to come down there now. You all agree with that? So what do we work thereafter? Turning point. So how do I work out the turning point? If prime x is equal to 0. So it's negative 3x squared plus 6x is equal to 0. So as you can see, negative 3x is a common factor. I'm left with x minus 2. So x is equal to 0 or x is equal to 2. But we know that f of 0 of course is minus 2. The graph is going to turn on this point here. And of course f of 2. I'll put 2 in here, I'm going to get negative 8 plus 3 times 4 minus 2, which is negative 10 plus 12 is 2. So 2 and 2. That 1.1 root 3 was 2 comma something now, or 3 comma something. What was it? 2 comma something. Okay. That's a bit over. Move 1 in there. So that's 1. That's approximately 2. 2 and 2. Okay, so as we said, the graph will come down. There's going to be your when the graph is going to turn on, you will always see me draw this here. That's 2 and 2. So we draw. The graph is first coming down. And there's the graph of. Okay. I did not ask for the point of inflection, but I'll do it anyway. How do you calculate the point of inflection? That's going to make it a different color that you know it's not part of the sum. Okay. It's a second derivative. Then I put the derivative. So what do I do with the second derivative? It's equal to 0. So x is equal to 1. You have sub 1 into the f of 1. It's going to give you 0. Not so, as you can see here. So the point of inflection is actually at your x-intercept. If they ask what is this is concave up, not so. There is concave up for x is less than 1, it is concave down for x is more than 1. Let's shift our attention to the geometric graph. X-intercept at y equal to 0. So 0 is equal to 3x squared minus 3x. Take out 3x as a common factor, I'm left with x minus 1. So x equal to 0 or x equal to 1. Okay. The y-intercept, of course, is 0. For your turning point, what do you do for turning point? First derivative, which is going to be g prime of x, which is 6x minus 3, and say that equal to 0. So x equal to 1. Get the corresponding y value by substituting a half into g of x. So a half of g of x will be 3 times a half. Did somebody work that out quickly? 3 times a half squared minus 3 times a half. 3 over 4 minus 1.5. I think it's going to be negative 3 over 4. Right? So negative 3 over 4. This point is going to be a half and negative 3 over 4. The turning point is going to happen at half and negative 3 over 4, which is about there. Okay, you can clearly see. Here we can clearly see that the tangent in question is actually going through there. Can you see that, people? So that's what the tangent will look like. Okay? And this is the equation. Y is equal to 3x minus 3. How do I know that? Because the point happens at 1 and 0. Okay. Next question. And that's it. That basically brings us to the end of chapter exercise. Okay. So we still need to do the optimization exercise. People enjoy the rest of the day. Good morning, class.